I'm going to put change, and in parentheses, or rather, and in quotes, I'm going to put transform. So when they say please transform the equation, they just mean please change it the way that they're going to say. Change equations. Okay, so write that down, Milo, so you can get that part down, and Carlos. And so in this case, what's the equation that they're going to have you change? I wrote one down. It's a simple one. So section A, the simple equation I'm going to write down is y equals 4x minus 7. That's old school, long time ago. Let's see what people remember from a long time ago, even though I still haven't turned off. For the slope right side of the room, we'll ask you for the y-intercept. So here it comes. What number is the slope?
4.
Yeah, 4. The number right from the x and you are the slope. Good old fashioned over there. What's the y-intercept?
Negative 7.
Thank you for saying that negative. Whatever the sign is, the entire thing. It's old school. So here's what they're going to say to you. Am I recording? Am I recording? Yeah, okay.
Yes.
What they're going to say to you is, please transform the equation so that the slope is now 5 and the y-intercept is now 8. Let me say it in English. Hey, please change this equation so that the slope is 5 and that the y-intercept is 8. So I'll write down the instructions and we'll see what you guess on your papers. I'll come around and check that off, and then I'll put the answer and you'll be like, that was it? I'll be like, that was it. So what do they want? They want them to, maybe I should do it below. All right. So here's what they want. They want you to transform the equation. So slope. Transform. So slope is, we want slope to be 5. And y-intercept. Sure, y-intercept. Maybe I'll put it over here. Y-intercept is, I said, negative 8. Write down what you think that's going to look like. I'm going to come around and check it off in a moment. For those who had it, good. For those who didn't, you definitely pay attention and write down. To change this guy, yeah, you literally just change it. They use the word transform. Sometimes it's something you do in geometry, but for this one, the 4, they want it to be a 5. So in this case, just turn it into a 5. They said they want the 7 to turn into a negative 8. Just turn into a negative 8. I think because it's so easy, and this is the A section, when I have you do your handout, I'm going to have you do A, B, C in the same order. I think the idea is they just want you to get used to the word transform. In picture form, to change these, it would move the picture around. It would transform it. But for the equation's sake, it just means to change. All right. Any questions on this one?
That was literally it. Yeah.
Here comes the second version. Again, the second version,
Again, I wasn't.
same concept, but a different equation. So let's start you with y equals, let's try this again. Let's start with, no, we're still in section A.
It's because my role was everybody to like it, but I'm not going to.
Y equals, nice and easy. 9 raised to the x power. Please write that guy down. Now this one I'm going to make you guess again, and then we'll remind you what the original equation was. Make them guess. Yeah, let's try. Okay. On this one, we want you to transform it. So transform equation. And write down the instructions, that way the words are there. These are the only two types I could get today, so I'm only going to do these two types. You could do a variety. I know I was trying to do that. Transform equation. This one, they only want you to transform one thing so that the y-intercept is, let's make the y-intercept 2. So I'm going to write down the formula for an exponential. So again, everybody remembers that stuff a long time ago. We've seen it a million times. The y, the slope, and the y-intercept. So here on this one here, if I could find my writing utensil, I can right now. Please write down the formula y equals ab raised to the x power. Now here comes the question that once we get the right answer will help us. Anyone know between the letter A or B, which one is the y-intercept, A or B? Yeah. A turns out to be the y-intercept. So A is the y-intercept.
Okay.
B has a different name, but we're not going to write it down. So it turns out, with the equation above, there actually is a number in front of the 9, which it's unfortunate that I didn't tell you that it was there, but I just want to see what you would do with it.
Oh no, I was.
Okay. Anybody know what number is in front of the 9? We don't see it, so.
It's a 1.
Okay. I heard 1. The original problem would have had a 1 in front of the 9. In other words, this problem is really y equals 1 times 9 to the x power. Okay. So now, make an adjustment on your paper. Please rewrite this equation, the one that has the 1 for the y-intercept. Please transform it so that 2 will be the y-intercept. Okay. Now it's no big deal, because once you know which number is the y-intercept, then transforming that or changing that is no big deal. Okay. Someone say out loud what the new function is going to be, please. Uh-huh. Uh-huh. Take a look at that. Now, see if you have any questions on it. The only big deal on this one is, will you be able to remember it? This will conclude kind of the A section. The A section is to transform. When you get your task or your mini quiz or performance task, that'll be there. Should I have them do one or more? No, if they need to change it to y-intercept being 10, red number turns into a 10. No big deal. Anybody know what the B is called, just in case they say anything about the B? The B is going to be called, let me circle this correct answer so that way on your papers, you can, if you want to put a line through your old answer, you can, so that you can have the new correct answer. The B is called the growth rate. So for B, put growth rate. That way, if they say, please transform it so that the growth rate is 7. You know, okay, I'm taking B, growth rate. All right. So once you write that down, we've addressed the. The word inverse is a word that is used when you're solving equations. When you're drawing a picture, the 3 pieces to get this will be, so find inverse of graph. I can find the inverse of a graph, and I want you to write down those instructions. And for me, it's easy, because I know there are 3 things I need to do. What's the first thing I need to do? I need to find the coordinates, make a table. Line of symmetry. These are the three pieces, line of symmetry. The words are going to throw some people off, but the three steps shouldn't be too bad. Line of symmetry, we're going to draw it. Line of symmetry. You want to draw that. Step 2, make a table. Table 1. Table 1. Original dots. It's going to be a lot, but once I do it, you'll be like, oh, okay, all that means just original dots or coordinates. I'll put original points. For this, I'm going to say we need 3 of them. And then the last thing, we're going to switch and graph. Switch dots. And graph. Again, I did section A, and this is section B. I did section A so that you can have an easy thing. So when you get your thing, there are 3 things that you need to do. Do A, oh, that's fixed. B, uh-oh. C is like, and then next when it's time to fix things that are broken. All right, Thomas. Well, what does all of this mean? Step 1. To find an inverse of a graph just means there is a line of reflection. In this room, the line of reflection will be right here. We want to mirror everything that's on one side to the other side. In other words, if you were to cut me right down the middle, okay, that's my line of symmetry. I just got to make sure everything on the left is on the right. The question is, how do we do that? Step 1, we actually draw that line. Now, the good news is this line is always the same thing. It has an equation. Here comes the equation to that line. It's going to be y equals x. Write that down somewhere. Y equals x is the equation of the line of symmetry when you're trying to find the inverse. The question is, okay, so that's the equation for it, but what does it look like when you put it on the picture? The answer is this. If you look at these little boxes, if you were to put a little point right here at the origin, I'm going to get rulers in a second, and you put a little point right here at 1, 1. You just go over 1 and up 1. If you connect those 2 dots, you have drawn the line of symmetry. You have drawn the picture that goes with the equation, y equals x. Will it always be that for the inverse? Yes, every single time. Now, I'm going to get a ruler for you all, and then I'm going to draw my line through, because that line is going to go from here, a dotted line, from the lower corner of the box all the way to the upper corner. That is y equals x. That is also called the line of symmetry, my LOS. Too much information. But what do they need? Hey, can I draw this little red line every single time? Pause this. He gets the answer. The dots here, and I'm only going to choose 3 of them. I'm going to write down their coordinates, and I'm going to put them in a table. Okay. Once I put their coordinates in a table, somehow I need these dots to jump over the red line. That's my goal. I want to reflect these dots over the red line so that they're the equal distance away from the red line. So how is he going to make them jump over? Here we go. Let's watch. Step 1, I'm going to choose the coordinates for this dot. I'm going to choose the coordinates for this dot. I'm going to do just 3, and I'm going to choose the coordinates for this dot. Okay. What does he mean? I'm going to choose the coordinates. Someone on this side of the room, and I'm going to need to build a table for it. I don't have space. I don't know where you're writing. You don't have to write your letters, but I am, because I don't have space. So this is going to mess some people up. X, Y. Someone tell me the coordinates of this first dot. 0, 3. No big deal. Unless you're not good. Everything a teacher writes, you write. Otherwise, it's not. All right, someone different. Please tell me the coordinates of the second dot.
2, 4.
2, 4. So far, so good. This is why I expect this section to be good. The only thing that would mess someone up on this is, I don't know. They just forgot.
Thomas, the 3 ways are each 3 ways that you can make the inverse of the graph.
These are all the steps you have to do to do it. So step 1, line of symmetry, got a red dotted line. That part's easy because it's always the same. Step 2 is writing the table for the coordinates. What's that third one? Someone different?
8 and 8.
8 and 8? Oh, okay. Oh, really? Fine. You sure that's 8 and 8?
I thought that was 7.
Is it 8, 7? All right, that's good. It's good that it's 8, 7 because 8 and 8 would have messed things up a little bit. Technically, the only way it would have been an 8 and 8 is if it were on the red dotted line. That's the only way that two numbers can be exactly the same. All right. So we've done step 2. Step 1, red line. Step 2, first table. Here comes step 3. Inverse, I'm going to have you write the word reverse above it. When you hear the word inverse, for the purpose of pictures, I just want you to know, we're just going to reverse the numbers. In other words, we have to do a second table. So we have table 1, switch the dots and graph, which is really table 2. I wish I would put table 2 in there. And on the screen line, I'm going to put reverse. So you will see, I'm like, oh, okay, guess what he's doing. He's going to make another table, an XY table, and he's just going to reverse the order of the numbers. Instead of a 0, 3, it's going to be a what?
3, 0.
Yeah, just reverse. Instead of a 2, 4, it's going to be a 4, 2. And then I'm going to pause so everyone can write in. And then everyone put in that last one without even saying out loud. If you need it, it's on the board. I'll pause it for a moment for everyone to catch up. And for those I need you to, ultimately, we're going to graph the green dots and connect those lines. All right, connect those dots. When we do, we have graphed the inverse. But again, for those who need to write in your stuff, you're doing the second table where we switch the dots. I really should have said switch the coordinates. And then we'll go from there. We're on page 10. This one's in the video. It never shows the page, which is good. All right. So again, the last step for those who try to do it, it indicates you can wait for me, which is fine. The 3 dots, whose original coordinates we wrote in, 2, 4, 8, 7. You are now going to, I wish you had a different color to do it in. You're going to now graph their reverse or their inverse.
Adjust the table and inverse it.
Say it again.
Can we adjust the table and inverse it?
You might miss out on part of the point of it. All right, I'm going to put my dots in. We're going to try and find an uglier picture that won't be as neat. Might not even be a line, but the idea will be, okay, I see this. We line of symmetry, first table, second table, voila, we're good. All right, third column, let's see if I can put my dots in. This 3, 0, 3, 0 is right here. The next one was a 4, 2. Where are you, 4, 2? You're probably right here. And his last friend, 7, 8. 7, 8. Where are you, 7, 8? You're right there. And if I had a ruler, and let me put in these points so they can see it. Wish me luck, wish me luck. Here I'm trying to connect these guys. Connect. There it is. Take a look. See if there's something you want to ask. What I want you to be able to see, though, it just flips over the line. The dots are in the exact same spot away from, away from the red line, the line of symmetry. That's what it means to find the inverse. It means to reflect something over a line. If I'm a dot, just jump over to the other side. Pause, take a look at it, see if you are okay. This is now time. Go to page 11. You're about to do a similar thing. It's going to look weird where the dots end up. So you're going to have to do some labeling and some stuff. So what are the 3 steps you're about to do? Step 1.
Line of symmetry.
Line of symmetry is step 1. Step 2.
Table.
Table of original dots. I did 3 with this line one. You may have to try and do maybe 4 because their picture is kind of weird. And then step 3.
Switch dots.
Switch
Red
dots.
table.
Now, connecting the dots on this second one is going to be a little bit weird, but I'll see how well you do. All right. take about 2 or 3 minutes to attempt to do those steps. Some of you will feel confused on the drawing of the picture, but watch this. If you do step 1, that line of symmetry, you're good. It's the same one every time, y equals x. Step 2, well, you can put down the coordinates of those dots on a table, so that part's not tricky. Switching them, put step 3 into green, that's not tricky. The tricky part on this one is going to be, what does this picture even look like? And that's the part where I feel I'll have to help you. But for now, those first 3 steps, I believe you can do them. And I'll be coming around and start to check those momentarily. Since this picture comes to the other side, we can make that guy come down. And maybe you can, and then Richard, you might be able to watch. Step 1, line of symmetry, all start at origin, angle 1, 1, connect that dot. I saw that. 2, I'm going to need some help on the table. All right, what's that first table? Give a coordinate.
Negative 4, 6.
Say it again.
Negative 4, 6.
Negative 4 and a 6. Someone do a different one?
Yeah.
Or keep going.
0, 6.
0, 6.
And then negative 2, negative 6.
Negative 2, negative 6. Now he used 3. If you would have put some of the others, let me try that. Are there some other coordinates in there that other people may have written that aren't already listed?
Negative 3, negative 3.
All right, negative 3, negative 3. And then I feel like there's one more, or that's it?
Negative 3, negative 1.
Negative 1, negative 3.
All right, so we have our table. And again, if you only did 3 and it helps you get it, let's say if you did this one, and this one, it may work. But again, the uglier the picture, the more dots you probably want to put in. But the principle is there. You have those. Step 2, we're going to write the reverse, also known as the inverse. I use reverse just because it's a regular word, but in another math teacher might not even use reverse. They'll say, okay, now write down the inverse, which just means to reverse the numbers. X, Y. So I got now a 64. You don't change the signs or anything, just switch them. Negative 6 and negative 2. And then notice that negative 3, negative 3, when you switch it, is exactly the same. The only time that happens is if that coordinate is actually resting on the line of symmetry. When you flip a picture that's on, I don't know how to say it, but that one won't switch. At this point, I like what you've done, but you have to produce a picture. How do I produce a picture? I take these green numbers and I try and put them where they go and try and connect the dots. So let's see here, 6, 4. Where are you, 6, 4? 6, negative 4. I think he's about right there. 6, negative 4. 6, 0, where are you, 6, 0? You're right here, 6, 0, I see you. Negative 6, negative 2. Now, if I were doing this, part of me would have put them in order. Like I did the first dot, the second dot, and come around. So that when there's time for me to connect the dots, I'm connecting them in order, but it may not be an issue here. Let's see, what do I have here? Negative 6, negative 2. Are you negative 6? And a negative 2. A negative 3 and a 3. Negative 3 and a negative 3. And a negative 3 and a 1. A negative 3 and a negative 1. Some of you can see the picture forming. It might not be what you would have expected, but now I'm going to connect the dots. Take a look at it and see if you're okay with it.
Yeah.
So again, what are the steps? Line of symmetry, original table, the second table that you reverse, and then you try to connect those dots. Now the question is like, is there a way I can tell if I got it right? Technically, if you had a ruler and you put your ruler from here to another dot, they should be the same distance away from the line of symmetry. That's kind of the way you know. If you can make a plus sign between one dot and another dot, If they're about the same distance away, then you're okay. Again, this picture is one of the most difficult types of inverse pictures. The other one we did that just had a line, oh, okay, it's easier, it just flips. You can see that. On the test or a quiz, it'll have the easier one. It won't have it super difficult. Okay. All right, let's pause. Any questions on this one? We're trying to decide whether we should do one more. This is section C, section C. There are 3 sections I have for today. This is the last, and then after this one, depending on how you feel, we'll be able to give it to you and have you work it out. You are going to find inverse of equation. All right, what are the steps in that? Step 1 is going to be switch. So it's like we did before, we switched the tables, but this time we're just going to switch x and y. Switch x and y. And then step 2, solve for y. Oops. So only 2 steps. It sounds nice and easy, but the harder the equation, the trickier this process is. All right, write those 2 down. We'll do easy, medium, and hard. All right, so the first example of this, and I don't know that you'll get a second one, maybe I'll give you another one. They all change so much. All right, so your example of this. Find inverse of the equation y equals, this is page 5, letter A, so y equals 3x minus 6. Thomas, please find the inverse of the equation y equals 3x minus 6. That's true, we could graph this. It would be a line, we put our red dotted line, find the dots, but they're not asking for all that. They just want us to do it just with the equation. Here it comes. Step 1, switch the x and the y. And let me actually make the y red so you can see that it's switched. I wish you had colors so you can see them. So here's step 1. Switch the x and the y. Oh yeah, I guess you could do it with a highlighter. Step 1 is nice and easy. Step 2, for those who are good at solving equations, step 2 for those who are good at solving equations is I just need to solve for y, get y alone. Well, to get y alone, just to tell you what I'm going to do, the number that's closest to the y, we don't mess with them right away. It's sort of like family. The 6 which is further away, it's sort of like it's like your cousin. The 3 is like your brother or sister. So if you were on a sinking ship or whatever, you have to get rid of your cousin first. All right, bad example. And then finally get rid of, all right, let's just do it. We'll go with it. In other words, hey Thomas, what would you do first on this problem? Step 1, I would, of course, add 6 to both sides, because I want to get rid of the 6 on this side. I want y alone. So I'll get rid of the 6 first, and what will that give me? So far I'm going to have 3y. The 6 is canceled. X plus 6, you can't add a 6 to the x. In other words, you just want to put in x plus a 6. So far, so good. No big deal. The next thing to do, and I hate to put 2 things on the line, so I'm going to rewrite this line down here so that when you look at your notes again, it doesn't look like there's 2 things there. I'm going to rewrite this guy. Everybody in line. Except for that y. I still want that y in red so it stands out. Once that y is alone, I did it. How do I get rid of a 3 that's being multiplied times a y?
Divided by 3.
We divide. In other words, we do the inverse. And that's what these things are. The inverse of 6 is the opposite. Not actually. None of the numbers are going to actually disappear. Everything's going to remain just all on one side. So basically nothing's getting disappearing. We run it with the y, that's by itself. Everybody else, you guys go on the other side.
Yep.
So if I were solving, let's say for Ashley in this room, we have everybody else on the side stand up and walk to that side. And once Ashley's on the side on her own, we solve her. Final answer. Here comes the final answer, so you can see it. Take a look at the answer.
Wait, can it just be x plus 2?
This is it. I wish I could do something different. This is it.
So we can't simplify?
You cannot.
Then what did we just do?
If it was 6 times x, then yeah, you'd be able to do something. But because it's 6 plus x, can't do anything.
Why are you trying to make it so complicated? Just leave it alone. It's
All right, take a look, take a look. Now this is the easy version of this. There are some harder versions of this. Let me see if I can find one for you to try to see what it does for you. And then, but let me see if there's another one of these so that at least you can do one of these on your own. All right, the new problem is find the inverse of y equals 4x plus 7. And what we're trying to do there is guarantee that at least one in this section you'll get. I'm not. Step 1, switch the x to the y. The y you can see is red. Step 2, let me get rid of that 7, my cousin first. Show your steps, that way when you turn in, if something is wrong, at least I can kind of maybe try and give you credit. So you do the right steps with the switch part, and divide that 4.
I was scared when I did one.
Yeah, but it's a cleanser, but it's
Take a look at the answer on the board. Make sure it's what you have on your paper. Hopefully you compare with someone ahead of that. Step 1, I saw people do it. They put that y equals the 4 radical x plus 10. Switch, here it comes. Everybody else. I saw that out there. That was good. Next thing, of course, get rid of that cousin first. I saw some people do with the next step, get rid of that 4 because it's multiplying by 4. We have to divide both sides by 4. And then that last part that some people want to ask, but I didn't want to give it away, so that at least they could be wondering, well, what do we do here at the very end? How do we get that house off of the thing? And I did see it at least in one place. Anybody know what the opposite or the inverse of square root is?
square.
To square it. So to get rid of this house, you have to square both sides. It's going to look like this, which I hate to put it on the same line, so I won't. That way, if you're writing notes and you have to look back at it later, you don't put two things on the same line. Yeah, you're going to do too much. So what is he going to do? He's going to square both sides by putting them in. There's that move right there. This is the move that I expected. Okay. I don't know if they're going to know that. But I did see it. I don't know how they knew it. And so now, I'll put that. That might be it. All right, I'll go ahead. All right, here comes the final answer. Write it down on a pause.
Which unit was it from?
I don't know. That's what I'm saying. On these last ones, I think there's get some feedback. Like, I don't think we did a lot of inverses, or it could have been in the B section. You know, sometimes we like didn't do the B section. Let me do a fake version of this one so that at least everyone has a chance. This one was it x equals? I'm gonna just put a y equals a radical x. Let's make it a plus. Last one was a. Let's make it a minus 12. Hey, do this one really fast. Do this one really fast. It's his brother. He looks just like him. The only difference is I decided to get rid of the 4. See if you're getting the inverse of this guy here, what you would do. Alright, here comes switch. Step 2, the 12. Step 3, to get rid of the house, you just square it on both sides. And the answer stays that way. You don't have to actually do any work. You're just getting that y alone, and that's how you know.
So did you divide by one time?
You don't divide. How many doesn't rock? Good question. All right. Page 22. Page 22.
We weren't supposed to do that to the y.
Third power. I think let me see if I try it with that or try it with a 10. We were about to try and do an inverse with that that guy up there. I'm gonna rewrite him and I'll write a version with the 10.
Which page was this one?
26. All right, so here it comes. Let's see if we can do this. Page 26 is where we are. There it goes. Y equals that. Is it a 3 to the x?
Yeah.
All right. The good news is to write the inverse, it starts off the same. Switch. Everyone can switch, even though it looks weird. Let me do this by writing calling blunt. That's page 26. Maybe page 26. How about that? That way it doesn't get part of the problem. All right. Y equals the 3x. Here comes the switch. X and a 3 and a y. Everybody can switch on an inverse.
No.
Step 2. Hey, how do I get this y down? Well, anybody remember how to get a y down from the exponent? Not radical this time. It's a word we use in Unit 4. There used to be an X up there. It's a balloon. We have to tie something to it to get it down to the ground. A log. We do tie a log to a balloon. And so here's what's going to be on the next line. So here it comes. Remember this guy here?
Yes, we do.
That guy there.
Oh, it's when we did.
Yeah, so now the y is going to come down in front. We're going to divide the log 3 under the log x. And voila, you're done.
Yay.
So this one is a tricky one, but here it comes. Let's see if I can finish it off. The y comes down in front.
Yeah.
And again, I recognize some brains are out of power at this point. I'm writing this down so at least you can see it.
All right.
And the last of the greens are going to go under each other. Let's see if I can do it. You know what I should probably do so that they can recognize that which green is under which. All right. Log 3. Log 3.
We're just in the same thing, basically, both ones. I think so.
And here comes the final answer. This is from Unit 4, this log stuff. Look at it though and to see if you want to ask something. I'm going to put one for you to do right next door to it. So at least you get one opportunity to try what I just did there. Basically, I changed the 3, but still write down all the steps. This is it. This is the last part of your brain that I'm using in terms of putting something in. Switch, and then you got to get that y down. The balloon's in the air, you tie a log onto it, and that brings it down.
Why is there a y in the middle? The red y between log x. Oh, do we put that there?
Everything up there is
I
did do a little faster from the last unit, but again, like I'm saying, there are 3 sections on this performance task. Section 1 and Section 2. Section 1, transform or change the equation. Section 2 is going to be change the picture, the inverse of the graph. Get your dots, table or original table, green table, graphic, and then this last section, which is here's an equation. Switch the y's and solve for the y. Because I'm about to give it to you in a moment. So I'll start writing this down. If you want to see this, that's fine. But look through section 1. If I do with the transform the equation, 2, can I get the pictures where I do the 2 tables and the red dotted line, the y equals x? And then 3, if I get one of these last guys, which ones are my best chance of being able to switch and solve for y? While you're doing that, I'm going to solve this one, x, y.
Put up. Wait up. 1 second. Right back, Thomas.
So don't you know I'm about to pass all the stuff.
Just take a quick moment.
I'm writing it. Hey, somebody, everyone don't listen to this. Just a couple of people listen to this. Log 10 equals 1. Not everybody listen to that. So technically, if you were here, the next line would just be y equals log x. Not everybody, don't listen to that. Everybody else, you just listen to divide log 10 on both sides. And your final answer is going to be still just log x.
Oh no, I did it all the time.
Yeah, my ocean.